lesson 5.4a, the remainder theorem. And then I'll put in a separate video, but just flash forward a little bit for you guys. There's also lesson 5.4, factor and rational zeros theorems. And so for both of these, we're back to dividing polynomials. And there's some cool tricks. There's a cool bag of tricks here. So here, I'll just put 5.4a in this video, and then I'll make a separate video for 5.4. And so what is this remainder theorem about? Now, this is a weird one, but turns out if you divide one polynomial by another polynomial, it's supposed to get a remainder. Interestingly, like weirdly enough, that remainder also represents the y value when you plug in the particular x value of uh, the binomial that it would have been divided by. Here, so let's look at an example. So we'll do a bunch of examples. It's the very first one. They have this one, it's on page 279. I'm just going to copy it straight on the paper. They say, what if you have p of x is equal to x squared minus 4x plus 7, right? Now, what if you want to know what is p of 5? Okay, well, you could just plug it in, right? You could just plug in 5 where the x goes and get the answer, right? But there's a weird way to do this too, which is what if, like, um, eh, see, what if you were to sort of divide this polynomial by x minus 5? Because if x were equal to 5 and x minus 5, then that's like dividing by that particular binomial. Okay? Now, I can do this with long division or synthetic division. And so I'll try both those methods, and then I'll do this, what we call direct substitution. So you just plug the 5 in. And let's see if we get the same answer, all three methods. We're going to find out. So here I'll start with long division, which uh, here, book didn't list as an example, but I'll try it out. Let's see what happens. All right, so what happens if I take x squared minus 4x plus 7, and I'm going to divide that by, let's do x minus 5. Is that what we want? Yeah, okay, because we want to know what happens when x is 5. So you see, like, if you have, I might treat this like x minus a, and a would be 5, or you can think it that way. Saw that before, like a couple lessons ago. And so how many times does x go into x squared? Well, x times. So that x times x is x squared. So this is a match as it should be for this long division. But don't forget, x times negative 5 is negative 5x. So I'll put that right here. Okay. Then I'm going to subtract this off. So subtract this from this. Okay, just remind you guys how long division works. Right, what I like to do is distribute this negative. So plus minus plus, right, and then just add going down, and just so you don't trip over the negatives. So this, of course, should zero out every time if you're doing this correctly. Then negative 4x and 5x makes x. Right, then drop down to 7. I'll do plus 7. Right. So now we got this right here. How many times is this x going to this x? One time. So I'll do plus 1. All right, 1 times x is x, of course. 1 times negative 5 is negative 5. Okay. So then subtract this off, distribute this negative, plus, minus, plus, like that. All right, 7 and 5 is 12. All right. Now this right here would be the remainder, because you can't really continue this process, right? X doesn't go into, well, anything less than x at that point, right? So right, this polynomial divided by, so x squared minus 4x plus 7, right, divided by x minus 5 is x plus 1. So this is your quotient, but there's also this remainder right here, okay? Now, what your book is claiming is that if I were to instead plug 5 directly into the original expression, I would also get 12. So the point 5, 12 exists. Here, I'll write that as sort of like the answer. 5 comma 12 is a coordinate on the original p of x function, this p of x right here, x squared minus 4x plus 7. Okay. All right, so now that was the long division method. I'm going to show you guys two other methods. Let's do synthetic division, and then I'll do direct substitution. So synthetic division. Okay. Now, synthetic division, here, if I have this kind of side by side, or this is a different way to think about this. We're just going to write these coefficients. Now, I do see that the power of x does decrease by 1. Oh, like we didn't skip the power of x. We got x to the 2, x to the 1, x to the 0. So I can copy the coefficients, which are 1, negative 4, and 7. Remember, with synthetic division, I haven't written anything about x. It's sort of implied there. Okay? And then when I divide by, I'll put this box over here. Well, I want to see what happens when I plug, say, like if you plug in 5, so you can just write 5 for here, right? Now, my long division example, remember I did x minus 5, that was long division. The synthetic division is like what x minus a, whatever a would be, which in this case would be 5, so I'll just do 5. Right, then I got this big bar right here. Right, now this is a process that you guys might remember from a week or two ago, so I'm just going to follow this process, drop down this one here, right? Then multiply it across, so say times this 5 right here. This 1 times this 5 is 5, and then you just add going down. Maybe 4 plus 5 is 1. Then same thing, I'll do times this 5 again. 1 times 5 is 5, add going down, 12. And oh, look right there. That is the remainder. Remainder. Okay. So what that means is that if you plug in p of 5, you get 12, right? Hence, there's a coordinate at 5 comma 12, right? Coordinate 5 comma 12, okay? Which is the same thing I got before with the long division. Here's the long division I did before, right? Here's the synthetic division version. I got the same answer. Okay? And finally, look, actually, before I go into direct substitution, I remind you guys really what both these full division methods are telling you. They're telling you this. They're saying take this original p of x function right here. Okay, so x squared minus 4x plus 7, and you divide by x minus 5, which is a little more obvious with the long division method, but that's also what's implied with the synthetic division version right here. Okay. The answer is, and they both give you the same answer if you know how to read these, right? Long division, it's really explicitly stated. It's x plus 1. Okay. And then there's this remainder of 12, so it's 12 over what was it, x minus 5, like that. Right. So if you were like answering a question on Alex or something and they want you to technical answer, I know the senior guys Alex questions, they look a lot like that, right? But you could have done the same method with the synthetic division over here, because that's what these numbers mean if you know how to read them. So you do an x squared over x. So in the quotient, you got x to the power 1, it's right here. And then this one means it has a coefficient of 1. Oh, that's 1x. And then you go down to just a constant 1. Oh, and that's this one right here. Okay, and here's your remainder of 12. So it's the same thing. So with the long division method, with the synthetic division method, okay, I got the exact same results. Okay? Now, remember what the whole lesson is really trying to get at, though. Like, what's the point of this? It's trying to say that if you plug in the target x value, you get that specific coordinate that you got from the remainder. So I'll go back to say, remember p of x, was x squared minus 4x plus 7. Okay. So let's see what happens when you plug in 5 for x. What's p of 5? Well, that'll be 5 squared minus 4 times 5 plus 7, which is 25 minus 20 plus 7. That's 5 plus 7. That's 12. Yeah, look at that. Okay. So now there's a coordinate at, okay, well, when you plug in 5 for x, you get 12 for y, 5 comma 12. Yeah. So that is one coordinate on this original polynomial, p of x. Yeah. So it just showed you guys 3 different ways how to do that. Right? And that's all the remainder theorem is saying. So pretty much the examples here are it's just that over and over. Right, so here, I'll go through these other 2 examples, right, and then I got a few questions highlighted here, so I'll do those with you guys. Right, so if you want to see, just a bunch more examples, right, you can see as many as you need here. Right, so it says, example 1 says use synthetic substitution to find f of -3 for this expression. So we got f of x is -2x to the power 4 plus 3x squared minus 15x plus 9. Okay, so there's your original function. Right, let's try here. I'll try three methods with you guys. I'll spell them out here. Long division. We can use synthetic division. And we can use direct substitution. And yeah, I want to remind you guys that all these methods should converge on the same answer. They should all tell you the same thing. So let's try long division. Right, so negative 2x4 plus 3x squared minus 15x plus 9. We're trying to find f of negative 3. So what's f of negative 3 equals what? Right, that's the target goal. Okay. Right, so if I want f of negative 3, I have to divide by like x minus negative 3, which would be x plus 3. That's what I did before, right? Yeah. Okay. All right. So we'll do that. All right. So how many times does x go into this first term? Well, I see x to the 3 times, right? And also this negative 2. Okay. So I got all that going. So multiply that out, negative 2, x to the 4, that should be. And then this times this, see, that's negative 6x cubed. Okay, I don't actually have an x cubed term. I'll have to keep that in mind when I go to synthetic division, but we'll hold on to that here for later. So this would be minus 6x cubed. Right, now remember I'm subtracting this off, so this could be like plus plus plus. Right? So this zeroes out, of course. Now, careful about here, because these are totally different terms. I got an x squared and I got an x cubed here. So I have 6x cubed. I do have a plus 3x squared, and I'll go ahead and drop down the negative 15x. If you want to drop down plus 9, you also could, but I would say that for later. And so how many times does this x go into 6x cubed? Well, I think that would be 6x squared times, and that times that, 6x cubed, as it should be. 6x squared times 3, that's plus 18x squared. Okay? Then subtract this off, so minus all this. Distribute the negative, plus, minus, minus. So this, of course, goes away. This is negative 15x squared minus 15x. At some point, I got to drop down to 9, so I may as well. Okay. All right, now what? How many times does this x go into negative 15x squared? That'd be negative 15x times. So negative 15x squared. Negative 15x times 3 is negative 45x. Right? Subtract this off. Right? So distribute. That's going to give me, this is plus 30x, and then I got a plus 9. Okay. Now, I think I can do one more iteration here, because x goes into 30x 30 times, so plus 30. Now, 30 times x plus 30x. Now, 30 times 3 is 90. Now I need to subtract this off. Okay. So plus, minus, minus, that'd be what? Negative 81. So negative 81. Now, negative 81 is the remainder. And what this whole process means, according to this remainder theorem, is therefore, all right down at the bottom, f of negative 3, that was the question, this is how I set it up. Okay? And this is the remainder, therefore, that's the y coordinate. F of negative 3 equals negative 81. Okay? So that's with long division. Okay, I just do long division. Let's try that with synthetic division. Okay, which is actually what your book is prompting you to do right here. Okay? So say, take the coefficients of this original polynomial. So I have negative 2 on x to the 4. Now, notice how they skipped over x to the 3? So you do have to have a placeholder coefficient of 0, which, yes, your book also has right here. But that's where that comes from, because there's 0x cubed. Okay, and if you forget to do that, then you'll get the wrong answer. I got a 3x squared, I got a negative 15x, and I got a 9. So I'm using the synthetic division method right here. So in this outside box, see, I want to know what is f of negative 3. So I'm going to plug, or I'll just put negative 3 in this box. We'll just push this through synthetic division. So drop down to negative 2, right, multiply by this negative 3, that's positive 6, add add going down. 6 times negative 3 is negative 18, add going down is negative 15, times negative 3 is positive 45, add going down, I think it's 30, and then 30 times 3 is negative 90, and then you get a remainder of negative 81 by adding down. Oh, that's the same thing we got before. Actually, I think this method was a lot faster, wasn't it? That's probably why your book is recommending synthetic division, because it actually is faster, right? If you have the right case to be able to use this. So what we just got, again, this is according to the remainder theorem, is that f of negative 3 is negative 81. Exactly what we got with this long division method over here. It's the same thing. Yeah, kind of put that side by side on the screen. Yeah, it's the same thing. Same thing. Yeah, same thing. Right. And last method I'll use here is called direct substitution. So what is f of -3? Here, for this one, I'll just go ahead and plug this in the calculator. So -2, got -3 to the power of 4. Notice I put the -3 in parentheses because when I raise that to some power, it also carries the negative with it, which I need. Okay. Plus 3, -3 being squared, minus 15, -3, and then plus 9. Right? Now, if this works, the number in my calculator has to be -81. Let's see if it works. Oh yeah, it totally is. It totally worked. Yeah. Right, crazy that, right? Right. Another example. They have a word question here. The total production of eggs in billions in the United States can be modeled by this crazy looking function right here, where x is the number of years since the year 2000. Okay, so the number of years are passing by. Sometimes there's more eggs or fewer eggs produced. Predict the total number of eggs in the year 2025. Huh. Well, that would be 25 years after year 2000. So I think we just need to plug in 25. Right? So sample 2. All right, eggs. It's really obvious what I'm doing here. Okay. So actually, here, I'll do this one backwards. Let's do direct substitution first. Direct substitution. So what is f of 25? Okay, so I'm just going to get the answer on my calculator screen, and then we'll go back and we'll test this remainder theorem and see if that also works. I mean, it's been working all along. It should. 0.00725 to the power 3 minus 0.149 times 25 squared. I'm just copying this expression right here. Plus 1.534 times 25 plus 84.755. Right, so with the direct substitution method, I'm getting 139.355. This is billions of eggs? I think, yeah, billions of eggs. Billion eggs. So I might call it 139 billion eggs. All right, so let's try, so that was direct substitution. Let's try synthetic division. Okay. So take the coefficients on this polynomial, which are 0.007, negative 0.149, 1.534, and 84.755. Okay. In this box, I need to plug in 25 for 25 years after the year 2000. Okay, and let's see this whole process. So 0.007, right, multiply 0.007 by 25. It gives me 0.175. Then add that going down. So plus negative 0.149. We didn't skip over any terms, so we 3, 2, 1, 0. Okay, yeah, want to make sure. 0.026. Multiply that by this 25. So times 25. That's 0.65. Add that to 1.534. That gives you 2.184. Multiply that by 25. So times 25. I'm getting 54.6. Okay. Then add going down. So plus 84.755. Okay. Let's see, moment of truth. There's only one number that should show up right here. And it's got to be what I got before with the direct substitution. It better be 139. And it is 139.355. Ooh, down to the 10, 100,000, down to the thousands place. It's exactly the same. It's identical. Yeah, so that worked. All right. So this is a pretty cool little trick. Right? All right, so let's see. Got a few highlighted here. I think what I'll do with you guys on each one of these is try both the direct substitution method and also synthetic division, and I'll throw in at least one long division somewhere along the way, yeah, just to do a little extra practice. So, yeah, let's try this out. So number 5, okay, they're kind of prompting synthetic division anyway, because it's probably faster. We got f of x is x cubed. Notice we skipped over x squared, so I'm going to write plus 0x squared, just so I don't miss that in the synthetic division process. Got minus 5x plus 2. Okay. And, well, they want both of these. You know what? Here, just to save time, I'll just pick one of them and do it. Let's do f of -5. How about that? F of -5, right, is what? Okay, so that's the question, f of -5. Right? So with direct substitution, direct substitution. F of -5 equals, I just pick up my calculator and punch in -5 everywhere I see an x, -5 cubed right here. Then -5, -5 being squared, and then plus 2. I just got -248. Okay. All right, so let's see. Does synthetic division with the remainder theorem also tell me the exact same answer? Let's find out. So I'm going to write these coefficients. So I got a 1 on my x cubed. I got a 0 on x squared. It's really important that you have that 0, otherwise this doesn't work. Got a -5 on my x term and a constant 2. Okay. What I want to plug in is -5. So in my box on the side, I write -5. All right, and synthetic division time. Oop, I was going to spell that out for you guys. Synthetic division method. All right, so drop down to 1 times -5 is -5. Add going down, -5 times -5 is positive 25. Two negatives make a positive. Add that going down, it goes 20, right? Okay. And then 20 times, let's see, let me go back to this real fast. Did I plug that in correctly? Got 5, 35. Ooh, okay. Or here, let's finish this up. So 20 times -5 is -100. Add that down, you get -98. All right. So I had to go back and check my work because this is actually messed up. Here, I just double check this. So let's try this again. -5. Whoops. All right, I had to reset my calculator. I don't know if I typed something wrong or if it went all squirrely on me. Let me try this again. 5, -5, plus 2. Yeah. This is not this. This is something different. -98. Okay. But it showed me the correct answer now. Okay, so we're good. We're on track. I wonder, did I square that? Is that what I did? Did I? Oh, that must have been what I did. Okay. So when I did the direct substitution, I accidentally squared this, and that's what threw it off. All right. No, we're back on track then. The answer is -98. Okay. All right. And then okay, let's keep on going. Number 13. Same thing. Here, let's try f of 2 on this. So 13. I got f of x equals x cubed minus x squared minus 2x plus 3. Okay. All right, so what is f of 2? Let's try that. F of 2 equals what? Okay. So with direct substitution, see what I get. So that'd be 2 to the power of 3 here, minus 2 squared minus 2 times 2 plus 3. I'm getting f of 2 is 3. F of 2 is 3. Yeah. All right. So let's try synthetic division. Okay. See if it's the same. Okay. So take these coefficients and okay, I have all my powers of x, 3, 2, 1, 0. So what are the coefficients? The coefficients are 1. I got a -1. I got a -2. And I got a 3. Since I want to plug in 2, I'll put a 2 in this box right over here. Right, and run through the process. So drop down 1 times that 2 is 2. Add going down, get 1. Times this 2 is 2. Add going down, it's 0. Times 2 is still 0. Add going down is 3. Oh, look at that. Right. It's a match. It's a match. So, bing, it's the same thing. All good. All good. All right. Let's try number 15. Here, 15. I got f of x equals x cubed minus 3x squared plus x minus 2. So let's do direct substitution for, here, let me try the other one. Let's try f of -1. F of -1 equals what? So f of -1. So if I plug in -1 this thing, let me show that variable trick I should have been showing you guys. So if I do second answer, add to that to the power of 3, right? Guess I got that. Minus 3 answer squared plus answer minus 2. I'm going to hit enter, but the first answer is junk. Don't worry about that. Okay, but if I type -1, enter. Okay, now the calculator's thinking, okay, -1, so about -1. scroll up, plug it into this expression. It'll tell me exactly what it is. It should be -7. -7. Okay, let's try this with the synthetic division method. Synthetic division. So I write these coefficients. Let's go 1, -3, 1, -2. Okay, I think that works. All right, we're trying to plug in -1, so plug in -1 right here. All right, so let's go through this method. Drop down the 1 times -1 is -1. Add going down -4 times -1 is +4. Going down is 5 times -1 is -5. Add going on -7. Oh yeah, it's the same thing. Same thing. Oh yeah. Math is winning. Winning. Okay. All right, so here, let's do. All right, I got a couple more highlighted for you guys. Do 21 and 22. Okay. So I'll do the same thing I've been doing all along, except maybe the last one I'll do one more long division with you guys. So 21, business. Advertising online generates billions of dollars for global businesses each year. The revenue from online advertising in the States from the year 2000 to 2015 can be modeled by this polynomial here, where X is the number of years since 2000, Y is the revenue in billions of dollars. Estimate the revenue for the year 2008, and then predict the revenue for the year 2022, assuming what's going on. Right? Well, I'll do one of these with you guys. So how about the year 2008? Okay, so 21A. Let's do 21A. Okay. So I got y equals, I'll write this bigger so it looks better on the screen. 0.01 x cubed plus 0.02 x squared plus x plus 6. Right? X is the number of years since the year 2000. Right? Right, we want the year 2008. So what if he, okay, so maybe if I treat this as a function like f of x, I know it says y, but I'll treat it like f of x. Okay. What is f of 8? What is f of 8? We're gonna find out. Okay, so I'll do direct substitution. I'll get f of 8 equals, I'll let the calculator tell me what that is. Okay, and then later on we'll do synthetic division. And it should be the same thing because it has been all along. So I've got 0.01 8 to the power of 3 plus 0.02 times 8 squared plus 8 plus 6. This is telling me 20.4. Was that billions of dollars? Yeah, billions of dollars. Billions of dollars. Right, so the number is 20.4. Let's try it with the synthetic division method. So, all right, I'm not missing any powers of x. The powers of x go 3, 2, 1, 0. So I'll copy down the coefficients as they are. Got 0.01. You could also express this as 1 over 100 if you wanted to. I got 0.02. That could be 2 over 100 or 1 over 50. I got a 1 and a 6. Okay. And then we're trying to plug in 8. So I'll put 8 in this box right here. Okay. So drop this down 0.01. Multiply by 8. That gives me 0.08. Add going down. 2 and 8 is 10. I think this is 0.1 exactly, isn't it? Right? Try that. And then multiply that by 8. That gives me 0.8. Add going down, it's 1.8. Now, what is 1.8 times 8? Let's see, times 8. That is 14.4. Add going down, so what is 20.4? And that is exactly what we got with direct substitution. It's the same thing. It's the same thing. All right, so I do one more with you guys from 5.4a. It's number 22, profit. Okay. Now, since it's the last one, I'll also throw in the long division method. Right, so just to round back to that again, too. We got profit in thousands of dollars, maybe. Clyde's Corporation can be modeled by, we got profit as a function of y, where y is the number of years after the business has started. I don't know why they went with y, but maybe just to change it up a little bit. Y to the 4 minus 4y to the 3 plus 2y squared plus 10y minus 200. Yeah, there you go. Got that. Predict the profit after 10 years. Ah, okay. So profit 10 equals what? Okay. So let's try three methods here. Do direct substitution. See what we get with this method. So everywhere I see a y, I'm just going to plug in 10. So that's 10 to the 4, right here, 10 to the 4, minus 4 times 10 to the 3, right here, plus 2 times 10 squared, plus 10 by 10, minus 200. All right, and all right, I get P of 10 equals 6100. Now that's the number on my screen. Remember, this isn't thousands of dollars. So this is thousands of dollars. Right? So as I'm doing this math, whatever method I use, direct substitution or synthetic division or long division, this is the number I should keep getting at 6,100. But keep in mind what that really means. So I'll put this in parentheses. That's the same thing as $6 million, right? Makes sense. Okay, so let's try a couple other methods. I'll do a synthetic division, a long division, and then we'll wrap this up and I'll switch over to 5-4. So let's do synthetic division. So take these coefficients. Now, I think I have all my powers of y. 4, 3, 2, 1, 0. Yeah, so we're good on that front. So the coefficients go 1, -4, 2, 10, -200. Okay. I want to plug in 10. So I'll put that in my box right over here. All right, and here we go. So I drop down the 1. All right, then times 10. 1 times 10, I got 10. Add going down, that gives me 6. Times 10 is 60. Add going down, 62. Times 10 is 620. Add going down gives me 630. Then times 10 would be 6,300. And then add these two together. Yeah, it's the same thing. 6,100. Again, the interpretation of that is thousands of dollars, but numerically, it's identical to the direct substitution method. It's the same thing. Same thing. Okay? All right, so one last method with you guys, which yeah, should be the same thing, is what if I do the long division? I'll go landscape on this. Let's go long division, just to fit in one more of these examples. Should know the same thing. So grab the full expression here. Y to the 4 minus 4y cubed plus 2y squared plus 10y minus 200. Okay? So long division. Now we're trying to plug in 10 years. So the way to do that with long division is to write y minus 10. Right? It's like x minus a, except instead of x is y, and then a in this case is 10. So pick it off that's. Right. So how many times does y go into y to the 4? Well, that would be y to the 3 times. So y to the 3 times y is y to the 4. But don't forget this, y to the 3 times -10 is -10 y to the 3. Now we're going to subtract this off right here. So I'm going to distribute this negative. Just like I did before. This, of course, zeroes out. This gives me 6y to the 3. Okay, then drop down my 2y squared, right, and then just rinse and repeat. I'm just going to keep on going all the way down. Y goes into 6y to the 3. It'll be 6y squared times. So 6y to the 3. My 6y squared times -10 is -60y squared. Subtract. That's going to give me 62y squared. All right, then drop this down plus 10y. So this would be, I think 62y times, wouldn't it? 62y. So that's 62y squared. The 62y times -10 is -620y. Subtract. So plus minus plus. That's going to give me, sports good way, 630y, I think. All right, then drop down the -200. Okay. All right, so y goes, this would be plus 630 times. So 630y, then minus 6,300. Okay. All right. All right. And we're getting down to the end here. So subtract this off. So plus minus plus. So this, of course, here's that. Now 6,300 minus 200 is 6,100. Is that what I've been getting with these other two methods? Because I did direct substitution, I did synthetic division. This is the remainder, which means it should be that value. Was it 6,100? Yeah, that's totally what it was. Direct substitution, synthetic division, and long division are all telling me the exact same answer. All right, so pretty good. That is a wrap on 5-4A.